I think most people have joined by now. So hi again to everybody. So the topic of today's webinar is how to extract building corners with the help of the new Xray function. So let's go straight to it. So most of us here are land surveyors. And the job that we have to do most of the time is draw a survey map. Now, a survey map will typically have on it some contour lines, some altitudes, maybe some cadastral borders and a number of parcels, roads, and some topographic signs. And these are all the things that we can put on the map from drone data easily. We can just export the digital terrain model, draw the contour lines out of it, and then turn on the ortho photo and put some topographic signs on our map. But one of the most important things on the survey map will also be the building outlines. And for that, we need to be able to define building corners. So this was one of the things we struggled with when we were drawing survey maps. So in the beginning, what we were doing when we did a big survey map, we flew over the terrain with the drone, made the digital terrain model in orthophoto, and then we just quickly measured the corners of the buildings with total station. So now we have a solution that will help us for this purpose. So here is a quick overview of today's session. So first, we make a very short introduction to the technique of measuring building corners that we use up to this point, something I'm sure all of you are very familiar with already. Then for the second step, we will check how Xray function works. So we will look at the theoretical aspect of it first to explain a little bit how it works. And then we will also look at how it works in practice. Then for the third part, we will try to analyze the accuracy of this data. So we will compare results from building outlines measured with Xray to those measured with the total station and check what kind of differences we can expect between the two. And then for the final part, my favorite session, so this will be the questions and answers. So if during the presentation you have any question, please write it in the question section. And then at the end of the presentation, we will go through all the questions and we will answer them. Right. Now, how we measure building corners. So the technique we are using, I'm sure all of you are using right now, is we map them with total station. So either we will use laser on our total station to measure them, or we will have someone signalize them with our measuring stick and we will measure them. So this method is very accurate, but it's also time consuming because we have to go to each corner and we have to measure it. We also know that measuring it, you have to know what you are doing, you have to have special technique for measuring it, and the accuracy we can expect for the building corners this way will probably be around 4 centimeters. The second option we have is define these building corners in 3D. So this is the other option that we have. It's faster than measuring them with total station, but it can be prone to errors because we can easily click on wrong point in point cloud. Let's see here. I have a practical demonstration. let's try to draw an outline of a complicated building in 3D survey. Right. Now let's see how we can define these building corners in 3D. So for this demonstration, I will use this building here and I will try to draw the outline of this building. So to make it slightly easier on me, I already have the ground classified, so it's showing up in red. So that makes the outline of the building better visible. So now let's try to draw its border. So here, and probably we should go here and in here and back to this part. Then quite quickly we get to the problem because this corner here is not very easily accessible. So I will try to click it up here and then we'll go back to this part. Okay, I already see that this one perhaps I did not click it as perfect as I could. Then we go here. Back here. Up here. Okay. Pretty hard one to define, I know, but it serves our purpose well. Okay. In here, let's see what we drew now. Okay. So we see when we check it out, we see that this could be done better. So already we see that we did not get all the corners correct. So what we could have done is select it here and try to fix it up a little bit like that. Again, chose a bad one. Maybe go down here. Not the best looking corners. So here is our challenge. How can we do that better? Okay. I tried my best, but the result was not very good. And this was not acting. I really tried to connect those outlines. So that's why now let's stop with introduction and go to the next feature that we have for this job. So it's called Xray. And what Xray does, it creates an image on which walls are better visible. So it makes walls stand out. It does that by showing only points that are on vertical planes. So points that are on a horizontal plane, like for example on the ground, will not show up. Those that are on the roof with an angle, they might show up, but they will be more or less transparent. So, and then where we have more vertical points, there the stronger the color will be. So the resulting image will look like an X-ray image of, for example, that we take when we go to the doctors to check our bones or something like that. Now, what is important for a good X-ray result? So obviously, it will be very important that we have walls defined pretty well. So we need to have point cloud created so that the walls of objects will be seen. So for that, we need to have some flights with oblique camera angles. So for that, one or two orbital flights should be enough. So if we are mapping an area, I would recommend you to make a regular flight with some top-down images, then two additional flights in orbital mode, one for example so that the camera angle will be 60 degrees and the second one so that the camera angle will be 45 degrees. If we do that, it's very likely that we will get a point cloud with very nice and well-defined buildings. That should be enough. You can also use the double grid flight mode with, for example, 60-degree camera angle. And you can use that one if you have a larger area and you would have to use too many orbital flights. You can also combine orbits and double grid, but this is already probably more than what we need. Okay, we need to have photos recorded so that we can see the walls of objects in 3D. And then the final step for good X-ray results will be correct settings for X-ray. So this one will actually be very simple. All we have to do is select the correct resolution and correct color transparency. So for 99% of the cases that you will do, I just recommend you to use 2 centimeters for resolution and 70% for color transparency. Now, let's also check how this technique works in practice. Okay, now let's look at how we can use X-ray in 3D survey. So as we said, for X-ray, what's important is that our building walls are nicely defined so that we have points on the walls of the buildings. So the use of X-ray is very straightforward. We have this button X-ray here, we use it. Then we have just two parameters to define. So first one is the resolution of our X-ray image. So here I recommend you to just always use the resolution of 2 centimeters. So that will be the size of a pixel in our generated image. Then the second parameter is color transparency. So this one governs how transparent the color of the points will be. So we tested a few different versions and we think that 70% works best. And there's the final option, transparent background or not. So let's use transparent background and press generate. The calculation takes just a few seconds. So it goes through all the points and it projects them onto the image. And here is the X-ray that we just calculated. So this one now has a transparent background. Earlier I calculated also one without transparent background. So you see there is a slight difference in how on this one the walls stand even more out because the background is now black. If we make it transparent, it has other interesting features. So why use the transparent background at all? Because this one can be combined well with ortho image, for example. So here I have ortho for this one calculated. If I turn on both of these, so now I have ortho with X-ray. This then makes the walls stand out on ortho image. So another useful trick to use. What I can do now is I can export this into one image. So in this case it's just important that we have the correct order here. So first we should have ortho and then the X-ray. If we export this into JPEG, just use the default settings. We will name it ortho with X-ray. Save, finish. Let's load that one back in. Like that. Okay, so now here we have three different options. And we can use whichever one we think will suit us best. So this is ortho with X-ray. This is X-ray with transparent background. And this one here is X-ray with black background. So on this one the walls are best visible. On this one we have the best view of this area. So now, okay, so this is how we get the image. Now how we can use it to draw the building corners in 3D. So for that purpose we go to the mesh section. I will turn the mesh on. So here is the digital terrain model calculated out of the ground points only. So what we will do now is we will simply drape an ortho onto it. So first, for example, we will drape this one, ortho with X-ray. Press calculate. So now basically what we have orthophoto with X-ray draped onto it, and already on this one we could draw the building outlines, so they look pretty well. Alternatively, we can also use another one. So let's click here, remove texture, drape orthophoto. So this one has the black background. So in that case the walls are even better visible. And the third option would be with transparent background. In this case we see the color from the digital train model and along with the white for where the walls are. Okay. Now let's see how we can use the cat section. Let's go to cat. So now for drawing the boundaries, it will be easiest if we actually turn the point cloud off. So we'll just go here to point cloud tab, turn off the point cloud, go to cat, select our building layer, make it current and visible. So here I actually already have some building outlines, but now we will just continue from where we left off. So I will start drawing a line. Now here I will select snapping to triangles. So that means snapping on the surface. So this is what I want to do. So we will start here from our endpoint, and then we can just draw like that. And I'm already drawing the edge of this wall like that. So the question here will be, where do we want to put our points? So will it be the outer edge or in the middle? So I would say put it in the middle, because you know the points, they will have an accuracy of about 2 centimeters. So I guess the middle will be the best choice for us. So like that. So one of the benefits of this technique is very often the walls of the old buildings will not be straight, and here we can see very well where we need to put the points. It's like that, and we get a very nice outline of the building. Because we are now measuring this on the ground, we immediately get the building outline on the ground level. So that is an extra added benefit. Okay, let's all this one. Let's not forget about drawing this one here. So when in doubt, so as for example here, maybe now let's switch a little bit to another texture. Remove this one, Xray photo, the one with black background, like that. I'll just, for a second, I'll turn the point cloud on. So yeah, here we see we have this kind of situation. So probably we should take the inner wall for the edge of the building. Turn it off. So like that. This should be the edge of this building. So here we see that the wall is not very straight. A ladder showed up nicely here. Like that. We'll add a point here and one here. So as you see, it's pretty straightforward, but let's later we will check also what the end result will look like. Okay, here we need to use nearest. Okay, let's just compare this with the building outline we drew earlier. Um, Immediately we see one thing. So the borders we are drawing now, they look a lot more reasonable. If we want to check them out well, what we should do is turn on the point cloud, go to CAD now, and let's see how we were able to define the edges. So here we see that the edges from the defined like this, we get them pretty well. So, and we can imagine how hard it is to measure this kind of a terrain with the total station. So here we have a lot of courtyards, and not a lot of points will be visible from one station. So this showcase that I am showing is actually from a real world example. So we were actually mapping this area before we had the Xray function. And what's interesting about this one is for this area we also have some prior measurements that were done by a third-party land surveyor who was doing this for the company that contracted also us. So what they did, they measured these courtyards here also with the total station. And what we can do now is we can bring in those measurements and we can compare the difference between the outlines that we defined and outlines that that land surveyor defined using total station. So for now I'll just turn off this defined in 3D borders that we drew earlier that aren't as nice. And now I will go to data, load CAD, and here I have the survey map that was measured with the total station. So okay, first things first, this one was drawn in 2D, so all the lines are at 0 altitude. So in order to be able to check them, we will go to top down and ortho mode, like that. So this will now allow us to accurately compare where we have the building corners and where these corners are measured with total station. To make it even more visible, we will turn off the point cloud, like that, go to CAD. Now objects are here in purple, we will make them thicker so they will stand out better. So okay, this purple, these are the building outlines measured by total station, and red is building outlines measured with 3D survey from Xray function. What we can do now is we can check what kind of differences we have. If I zoom in here, so here was a point measured, so this corner here, we see that here we maybe have about 2 centimeters of difference. Let's go to, okay, so here was the point measured by a land surveyor and here's ours, so they are pretty similar. I would say that ours is more accurate one, but of course here the land surveyor struggled because probably he had his station in here, so from here he was able to take most of these corners. Then he probably moved in here in order to take the corners that are visible inside of this courtyard here. Then his problem was that this courtyard back here he wasn't able to see, so he just uh, probably what he did was he saw this corner, and when he was drawing the map he just took this line and added it here and said, okay, here goes the back side of the wall. So here was a small mistake that he made. If we check how we defined the walls, we see that with 3D survey we were able to take all the small details, we were able to define the walls more accurately because it was easier to put those points here. You don't have to move there with your signal and signalize the point. We can go here and we can check what the difference is between the points measured. So if we go here and we try to measure the 2D distance between these 2 points, it comes to about 2 centimeters. So 2 centimeters, oops, that's less than what would less than the accuracy of the measurements most of the time. So let's go around here, this one as well. Okay, here we have another one, so this will again be approximately 2 centimeters. Try to make this one a little bit bigger for us. So here it says 7 centimeters, but the question is which one is more accurate. If we check it here, the difference is 6 centimeters. So obviously again here for this corner, here a mistake was made by land surveyor because he just connected it like that straight, but actually the wall goes out like this. And if we check, for example, here, again 6 centimeter difference. Okay, again here we see that this line is probably off a little bit. Other than that, in general, both of these measurement types, they fit together pretty well. Let's check the accuracy here. Let's measure 5 centimeters. Check for this one here, 20 centimeters, but obviously here the photogrammetry is way more accurate because here we see this goes into wrong direction. Check it, for example, here. So I don't want to check the corner, but we should check it like this on the nearest point. Hard to measure because they are too close together. So all in all, what we see is that the traditional measurements and X-ray building corner measurements are very similar, about 5 centimeters apart, but we should remember that we are talking about 2 completely different measuring techniques. So one was done a lot earlier, so even if we were comparing 2 different total station measurements for the building corners, we would probably expect a difference between 5 centimeters, because for this kind of measurements it's very important where you where you measure the wall. So in short, what we should bring back from this one is that the accuracy that we can achieve uh, from measuring the building corners with this technology will probably be just as good as it is with the total station, with the added benefit that the measurement is faster and we are not making so many gross errors, like for example this one here, this one back here, or this one here. So here we see again a point was measured here, point was measured at the back, and the wall was connected with a straight line, but the wall will not always be straight, so we might miss this kind of, we might make this kind of error. So right, now let's go back to our presentation. Okay, now what benefits does this approach deliver? So first of all, if we work in this manner, it's a lot easier to work. So it's a simple approach. It's a very fast one. We saw how fast we were able to map almost all of that area. So it took us less than 30 minutes, which makes it considerably faster than using a total station. And it is less prone to errors. So we are less likely to make a gross error when connecting some building outlines. Also, it will be a lot easier to access the back sides of the buildings that are sometimes very hard to reach with a total station. And the technique should be accurate enough. So in our demonstration, there was usually about 5 to 7 centimeters difference between total station and photogrammetry measurements. So if the difference is on average 7 centimeters, if the accuracy of total station measurement is about 4, then from that we can expect the accuracy of X-ray photogrammetric measurements will be around 4 centimeters, maybe something like that. Don't take my word for it. Test it out for yourself. When you do a survey map of an area, measure some corners with a total station, try to measure the same ones from X-ray, and see how similar they will be. So for the end, I think most of you have already seen this kind of graphic. So this is a good example for survey work. Usually we say, if you want to have a good result, it can be fast, but it will be more expensive. But you can never have a good, fast, and cheap result. So with this technology, because it makes our work easier, this will actually be possible. We can get good results that will be fast, but because this is a new technology, it does not need to be cheap yet. So we can have some profit with it. Now, on this bombshell, I would like to go to our final part. This is our questions and answers session. So let's check the questions that we had. So one question that we have already answered is Anton was asking us, isn't draping over the mesh distorting the walls? Well, it's not really distorting the walls, because what we do is we drape on the digital terrain model. Even with total station, we usually measure the building corner at ground level. So the mesh in this case only gives us the altitude of the corner. So for 2D, it will be in grid. So it will be, if the building is perpendicular, it will still come out perpendicular. So this is not like when we have, for example, roofs of the buildings projected onto the ground and they get distorted. If we use traditional orthophoto, here this is not the case. So the walls will not be distorted because if we are draping them onto digital terrain model, we should always drape them on the digital terrain model to get the best result. Okay. Question number 2 from Anton. Again, is it possible for the program to use X-ray data internally to improve the orthophoto calculation for roof positions? It is difficult to achieve accurate orthophoto for buildings with less than 100-meter flights. Okay, it's not yet possible to use X-ray internally in order to improve orthophoto, but we are actually right now finishing the new orthophoto algorithm, which will improve the roof positions by a lot. So we are working on a new algorithm. I think hopefully it will be out in a month or so, and that one will be a true orthophoto algorithm which will have perfect roofs. So it won't need to rely on X-ray to achieve that. It will work differently. Now, an interesting question again. Does X-ray work with LiDAR point clouds? Yes, of course. So we didn't show this one yet, but you can also import LiDAR point clouds and make X-ray out of it. And you can use then that X-ray to again draw the survey maps. So these are the questions that we have for now. So I guess everything is pretty clear. We also made a good timing, finished the presentation in 45 minutes. At this point, I would like to thank all of you for attending. So if you missed a part of this webinar, don't worry. Everyone who registers always gets an email with the recording, which you will be able to see and go back to check for some details. With that said, thanks again for joining and happy 3D surveying. Bye bye.